Okay, we've been talking about half-life, and just as a reminder, you're going to use the decay model. And so if whatever you're dealing with has a half-life, think of this as the original has to be more. So I'm going to say the original is 100. It could be 100 million, 100 grams. But then the final is going to be half of that. So it would be 50 out of 100. I'm just using random numbers, but that also translate to percentages. So if you had a half-life, really this is what you'd be looking at. So to solve this, you would divide by that initial amount. Well, notice you get 1/2 equals e to the kt. That's why we refer to it as a half-life. So on problem number 28, it gave us this model that we were just looking at, and what we know is the half-life is 7,340 years. Okay, so it doesn't tell us anything else. So just look at that first sentence. You could let the a sub 0 and the a be whatever you want, but if it's a half-life, when you divide by that a sub 0, it's going to be 1/2 equals e to the kt. Now what we do know is the t in this problem. So we know that t is 7,340. So now we can actually solve for our k, because if we don't have our k, we really can't solve for much more. So we have the natural log of 0.5 equals 7,340k. And then we're going to go ahead and get k by dividing. Make sure you know that's a 0.5. And of course you could write it as 1/2. I need to put that as a 4. And so my k is approximately, it's decay, so right, it's going to be negative. And I'm going to round this at some point. But when I go to plug it into my calculator, I'm going to use that A and S feature. So now for 28, this was all from the first sentence. So this is all from that first sentence that is telling me that I have a half-life. Now, to answer the question, I needed my K, which I found. It says, how long will it take for a sample of this substance to decay to 20%? So it's no longer half of the original, it's 20% of the original. Well, think about it. These numbers could be whatever you want them to be. I'm going to start again with my decay model. But if the original is 100, the final is going to be 20. Because notice when you divide by 100, that's 20%. So you may not need to do that every time. See if I can move all this up. If not, it's going to be a problem. Okay, it's not cooperating, so I'm going to keep going. So this is 1/5 equals e to the k, which remember, I do know my k is negative, and of course I'm going to plug this into my calculator. So from here I can take the natural log of both sides, so ln of both sides. I'm just going to have to write the rest over here. So I have the natural log of 1/5 equals, and this is of course an estimate, negative point. I have a whole bunch of zeros. I think I have 4. And then I would need to divide by that value on both sides, of course. Now, this is where in your calculator, You should still have your K when you did the natural log of 1/2 divided by 7,340. You should have your K in there. And now when you type in the natural log of 1/5, or you could do the natural log of 0.2, then you want to divide it by your answer. So you don't have to enter that decimal. You shouldn't have to enter it into your calculator. You want to use the A and S feature. So you'll hit second and the negative. And this should give you, I think I'm going to round to the nearest years. I think it was 17,043 years.